Hello everyone, my name is Siddharth and I am presenting this paper titled on Modeling and Simulation of Fast Autonomous Exploration and Mapping System for a GPS Denied Unknown Environment using ROS, which was written with Dr. Kumar and Priyadharshini. Myself from the School of Mechanical Engineering and the other authors of this paper are from the Electrical Department and all of us are from SASTRA deemed to be University, Tanjavur, India. The main focus of this work is to map a completely unknown environment precisely and to come with a solution which has higher operational time and also to complete the mapping process in a very quicker time without compromising the exploration quality. From the existing solutions, we picked up the unmanned ground vehicle system for exploration developed by Regent and Australian Droid. These robots are structured similar to cobot arrangement and have their unique and end effector to inspect, collect and monitor the environment. The second existing technology analyzed is drone-based exploration process. This system shown is developed by Barrick Gold and US Inc., which is used to travel inside a completely covered cave and it explores that. This system holds a better advantage of reaching any point inside the environment and also have the capability to move even in any steep paths. The drawback inferred in this approach is generally drones have less flight time and affects the operational time. This system also lacks in carrying a heavy sensor setup to investigate the environment. To overcome these, we propose this study. From the existing systems which are used to map an environment where the features are partially or completely unknown, the unmanned ground vehicles are used. These have the capability to handle heavy equipments which includes high rated battery modules for longer operational endurance and also can carry sensors with heavy mass to the field to infer about that environment. So these AGV system lack in terms of reachability as they can reach only to the extent of what mechanism it has been installed with. To overcome these, drones are used. These drones can reach any position in a 3D space. In spite it overcome the issue that the AGV suffers, this aerial system lacks in payload handling and also lacks in the longer operational time. Our proposed system ensures that it addresses all of these critical factors. This work proposes a multi-robot exploration solution which can handle exploration process in human restricted zones and also aids the computational complexity that usually occurs in a single AGV or an aerial drone setup which was currently used in the market. Since our system bears multi-sensor setup, the overall field of view of the system increases and almost covers the complete 360 view, which helps the system to extract the environment information in a quicker time. Our setup has aerial robots which increase the reachability factor and also due to the availability of strong battery backup, the proposed system will have a higher operational time. The dynamics formulation of the proposed method is derived using the Newton-Euler approach. The left side second order differential equation represents the relation between the motor torques and the input to the state of a mechanism wheel omnidirectional drive. The right side denotes the state input of a 6 degree of freedom aerial system. The proposed work is formulated based on these two fundamental dynamic equations. In this slide, we'll discuss about the decentralized approach used in the study. First is coordination strategy, which talks about how robots communicate and achieve a consistent view of the priority order. The second is individual planning, which briefs about how each robot replans its trajectory given information about the environment and the plans of the other robots. The major question needs to be addressed here are, can we use any algorithm that can plan paths which could avoid the obstacle in a space? The answer will be no. It depends on the application. In this study, we use hierarchical cooperative tip planner for the robot in the system to navigate. All the paths of the other robots are marked in the reservation table. The proposed ideology is validated using Ross gazebo framework. Gazebo's inbuilt models are used in this work for validation. In this system, hectare quadrotor model is used for aerial drones and the Nexus omni-wheel drive robot is used for the ground robot. LiDAR sensor, depth camera module and other sensors used in this simulation are also from the Gizebo library. The field of view of the depth sense camera module is matched with the real hardware specification of Intel RealSense D43i setup to make the validation near to realistic. Similarly, the LiDAR specification are set to RP LiDAR specification for more reliable real-time validation. In this work, leader follower concept is used for the navigating the multi-robot setup. The entire robot setup size is taken as single robot footprint and the path planning is done from the leader ground robot. Rest all robots target position are calculated based on the leader bot's planning. This, the result of this study is depicted in this slide. The left side video shows the entire mapping process of a completely unknown environment which we had created. This video is also available in my YouTube account and also I have shared the link for the same. The right top table depicts the mapping efficiency of the tested setups along with the time taken for the setup to map 90% of the environment. From that, we can clearly infer that the proposed system has a good track of the mapping efficiency and also have a decent time record for the mapping process. The picture below to the table depicts the mapping region versus time graph, which also states that our proposed setup has a good inclination towards a better performance. I conclude the study discussed. The suggested approach is found to be substantially decrease the time needed and the distance traversed by the proposed system to map an environment when compared with the conventional closest frontier exploration algorithm. The route followed by the suggested system throughout the mapping process is also found to be simpler and more efficient, thus demonstrating the efficacy of the proposed exploration method. In future, each robot will be equipped with a stereo sensor to process the data and find the obstacle and plan the path accordingly to avoid these obstacles. I am grateful to all my colleagues and faculty for carrying out this study at SASTRA deemed to be University, Tanjavur, India. Thank you.